Good evening, dear listeners. As the day gently fades away and the world begins to settle into a tranquil calm, I invite you to take a deep breath and allow yourself to unwind. This is your time to relax, to let go of the worries that may linger in your mind, and to embrace the soothing embrace of sleep. Tonight, we embark on a journey into the serene depths of ancient history, exploring a topic that, while seemingly mundane, holds within it the whispers of a distant past, the evolution of ancient Greek pottery kiln temperature records. In the soft glow of the evening, as you settle into your comfortable space, let your thoughts drift like leaves on a gentle stream. The world of ancient Greece, with its rich tapestry of culture and innovation, is a fascinating backdrop to our exploration. We'll navigate through time, uncovering the intricate details of pottery kilns that once brought life to clay, transforming it into beautifully crafted vessels that served both practical and artistic purposes. As we delve into this narrative, we will unravel the story of how these kilns operated, their roles in daily life, and the meticulous methods employed by ancient artisans to achieve the perfect temperature for their creations. You might wonder, how can such a topic induce relaxation? Well, dear listeners, it is in the very simplicity of the subject that we find comfort. The steady rhythm of the kiln's heat, the careful monitoring of temperature, and the dedication of the potters create a peaceful backdrop, allowing us to drift into a state of tranquility. We will begin by exploring the evolution of kiln technology, tracing the steps from rudimentary structures to more sophisticated designs that mirrored the advances in ancient Greek society. Notice how the physical warmth of the kilns parallels the warmth of community, craftsmanship, and culture. With each detail laid bare, you will find a gentle cadence to the narrative, lulling you further into a state of relaxation. As we move forward, we will examine the significance of temperature records, how they were meticulously noted, the importance of precision in achieving artistic excellence, and what these records reveal about the potter's understanding of their craft. Picture the potters of ancient Greece, surrounded by the fragrant clay, their hands skillfully shaping the earth into art. Imagine the quiet concentration as they monitored the temperature, ensuring that every piece emerged from the kiln not only intact but transformed into a work of art. Throughout our journey, you will discover that even within the seemingly dull realm of temperature records lies a world of creativity, innovation, and tradition, all contributing to the rich history we celebrate today. As we approach the end of our exploration, I encourage you to allow your thoughts to drift and float, just as the ancient Greeks did in their artistic pursuits. This journey is not just about pottery, it is about finding peace in the knowledge of the past, a reminder of the enduring human spirit and creativity. So, dear listeners, as we prepare to transition into the main content of our calming tale, I invite you to relax even deeper. Allow your eyelids to feel heavy, your breath to become slow and steady, and your mind to embrace the soothing cadence of history unfolding. Let the gentle rhythm of our exploration guide you into a restful state, as we delve into the sleepy streets of ancient Greece, where the warmth of pottery kilns whispered stories of artistry and innovation across the ages. Now, let us begin our journey together, as we uncover the charming world of ancient Greek pottery kiln temperature records, where every warm ember tells a story waiting to be told. The evolution of pottery kilns in ancient Greece, particularly their temperature records, is a subject that has garnered scant attention in the annals of classical studies. Nonetheless, it is crucial to delineate the historical trajectory of these kilns, their architectural configurations, operational procedures, and the quotidian practices associated with their use. The earliest documentation pertaining to pottery kilns can be traced back to circa 3000 BCE, in the region of the Aegean Sea, specifically on the island of Crete. Archaeological evidence from this period suggests rudimentary kiln structures, primarily constructed from unfired clay. These early kilns operated at relatively low temperatures, estimated to be around 600 to 800 degrees Celsius. The kilns were typically circular in design, featuring a domed roof and a floor that served as the base for the pottery to be fired. This architectural style can be attributed to the limitations of material technology available during this period. By approximately 2000 BCE, there was a significant evolution in kiln architecture, particularly in the Cycladic Islands, where the introduction of fired brick allowed for the construction of more robust kiln structures. These kilns featured a more sophisticated flue system to facilitate the escape of smoke and gases, which in turn contributed to a more regulated firing environment. The temperature records from this period remain largely speculative due to the lack of written documentation. However, it is widely acknowledged that advancements led to an increase in firing temperatures, reaching approximately 900 degrees Celsius by 1500 BCE. The introduction of the potters will around 3000 BCE, credited to the Sumerians and subsequently adopted by the Minoans, further transformed the pottery production landscape. This technological advancement not only streamlined the shaping process but also necessitated more precise control of kiln temperatures to accommodate the newly crafted vessels. Consequently, the kilns were adapted to meet these demands, leading to a proliferation of specialized pottery workshops throughout Minoan Crete and the surrounding Aegean islands. During the Mycenaean period, approximately 1600 to 1100 BCE, the development of large-scale pottery production prompted a more systematic approach to kiln temperature management. Administrative records, such as those found in the Linear B tablets from the site of Knossos, indicate that there was an organized effort to standardize firing techniques. These records, while primarily concerned with the distribution of goods, also allude to the importance of controlling kiln temperatures for the production of high-quality ceramics. It is during this period that kilns began utilizing ventilation systems that allowed for more efficient combustion of fuel sources, thereby increasing the maximum achievable temperatures. By the 8th century BCE, the pottery kilns of ancient Greece had evolved into more complex structures featuring multi-chamber designs. This architectural innovation allowed for the simultaneous firing of multiple batches of pottery, greatly enhancing production efficiency. The kilns employed a combination of clay and stone materials, often incorporating a domed ceiling supported by a series of arches. The maximum firing temperatures during this period are estimated to have reached between 950 and 1000 degrees Celsius, as evidenced by the vitrification of ceramics from this era. The rise of city-states in the 6th century BCE brought about significant changes in the organization of pottery production. Workshops became more centralized, and the need for standardized temperature records became paramount. The administrative procedures of these workshops were meticulously documented, often involving detailed accounts of the materials used, the types of pottery produced, and the kiln temperatures recorded during firing. It is during this time that the earliest known temperature measurement devices, although rudimentary by modern standards, began to emerge. These devices, likely composed of fragments of clay or metal that would react to heat, were employed by potters to estimate firing temperatures. Daily routines in these workshops were characterized by a regimented schedule that emphasized efficiency and precision. Potters would typically begin their day at dawn, gathering clay from designated sites, often located near riverbanks or clay deposits. The clay was then processed through a series of steps, including kneading and wedging, to ensure uniform consistency. Once prepared, the clay was shaped into desired forms using the potter's wheel or hand-building techniques. Following the shaping process, the pottery was allowed to dry for a specified duration before being loaded into the kiln. The loading of kilns was a highly organized affair, often involving the meticulous arrangement of pottery to maximize space while minimizing the risk of breakage during firing. Once the kiln was loaded, the potters would ignite the fuel source, typically a combination of wood and other organic materials, and monitor the temperature throughout the firing process. The importance of maintaining a consistent temperature within the kiln was underscored by the need to achieve specific aesthetic qualities in the finished pottery, such as glaze development and color uniformity. As the 5th century BCE approached, the techniques employed in kiln construction and temperature management continued to evolve. Notably, the introduction of the updraft kiln allowed for more efficient heat distribution. This architectural advancement was characterized by a vertical design that enabled hot air to rise naturally through the kiln, thus improving fuel efficiency and achieving higher temperatures more rapidly. Archaeological findings from sites such as Athens and Corinth reveal that these kilns could reach temperatures exceeding 1050 degrees Celsius, allowing for the production of intricate and finely detailed ceramics. The administrative practices surrounding pottery production also underwent transformation during this period. Workshops began to maintain more comprehensive records of kiln temperatures, firing times, and material usage. These records were likely kept by overseers or master potters, who were responsible for ensuring that the production met the quality standards set by the market. The daily routines of these workshops became increasingly formalized, with specific roles assigned to individuals, such as clay preparers, shapers, kiln loaders, and overseers. By the Hellenistic period, around the 3rd to 1st centuries BCE, the advancements in kiln technology had reached a zenith. The emergence of the downdraft kiln, which allowed for even greater control over firing conditions, marked a significant milestone in the evolution of pottery kilns. This architectural design featured a unique airflow system that facilitated even heat distribution, thus minimizing temperature fluctuations and enhancing the overall quality of the finished products. The meticulous nature of kiln operations during this period is evidenced by the surviving pottery from various regions, which display remarkable consistency in style and quality. Records from the city of Pergamon indicate that potters were not only concerned with the aesthetic aspects of their wares but also with the technical precision of the firing process. The integration of scientific principles into everyday practices became increasingly pronounced, as potters began to experiment with different fuel types, additives, and firing techniques to achieve desired results. In conclusion, the historical account of the evolution of ancient Greek pottery kilns and their temperature records is one marked by a gradual progression of architectural innovations, administrative practices, and daily routines. From the rudimentary kilns of the Minoan period to the sophisticated downdraft kilns of the Hellenistic era, the journey reflects a continuous striving for excellence in pottery production. The meticulous documentation of kiln temperatures, while often overlooked, provides invaluable insight into the technical prowess of ancient potters and their enduring legacy in the realm of ceramic art. The construction methods and materials utilized in the creation of ancient Greek pottery kilns exhibit a notable consistency across various regions and periods, reflecting the technical knowledge and resource availability of the time. Typically, kilns were constructed using locally sourced clay, which, when fired, provided the requisite durability and thermal resistance essential for high-temperature firings. The predominant clay types used included red clay and light-colored clay, both of which were abundant in the Attic region, particularly around Athens, where significant pottery production took place from the 5th century BCE onward. The structural design of kilns varied, but a common model involved a circular or rectangular base, which was often elevated to facilitate airflow. The walls of the kilns were generally thick, measuring between 15 to 25 centimeters in width, to effectively insulate the interior and maintain stable temperatures. The roofs were typically arched or domed, allowing for the efficient use of space and promoting even heat distribution. Evidence from archaeological sites, such as the kiln remains at the Kerameikos, indicates the use of bricks made from fired clay, which were employed in the construction of the kiln chamber itself. The firing chamber was usually separated from the flue, through which smoke and gases were expelled, by means of a partition wall. Maintenance procedures for these kilns were critical to ensure their longevity and effectiveness. Regular inspection of the kiln structure was necessary to identify and repair cracks or damages that could compromise the integrity of the firing process. Potters often utilized a mixture of clay and sand to patch damaged areas, ensuring an airtight seal that was essential for efficient operation. Additionally, the interior of the kiln required periodic cleaning to remove ash and residual materials from previous firings. This cleaning process was typically conducted after each batch of pottery was fired, utilizing simple tools such as scrapers made from bone or wood. The financial records pertaining to the construction and maintenance of pottery kilns are sparse, yet some inscriptions and accounts from ancient Athens provide a glimpse into the economic considerations of pottery production. For instance, a financial account from the late 4th century BCE references a payment of approximately 100 drachmas for the construction of a new kiln, which included expenses for labor and materials. Additionally, routine maintenance costs were recorded, averaging around 10 to 15 drachmas per month, primarily for the purchase of clay and labor associated with upkeep. These financial details reveal that managing a pottery workshop involved significant expense, with kiln-related costs constituting a considerable portion of the overall budget. Personnel involved in the operation of pottery kilns were typically organized into specific roles, each with clearly defined job descriptions. The master potter, often the owner of the workshop, oversaw the entire production process, from the initial design of pottery pieces to the final firing in the kiln. This role required extensive knowledge of both artistic techniques and technical firing processes, as well as an understanding of the economic aspects of pottery production. Supporting the master potter were several assistants, who were responsible for various tasks. The shaper was tasked with molding clay into desired forms, while the decorator applied intricate designs to the pottery, often using slips or glazes that required precise firing temperatures to achieve the intended visual effects. The kiln attendant played a crucial role in monitoring the firing process, ensuring that the kiln reached the necessary temperatures for optimal results. This position required knowledge of the kiln's temperature profiles, as well as the ability to make adjustments based on the materials being fired. An analysis of the personnel structure in a typical workshop during the 4th century BCE indicates that a small workshop might employ anywhere from 3 to 5 individuals, whereas larger operations could see personnel numbers rise to over 10. The technical specifications of ancient Greek kilns were dictated by the intended output and the specific requirements of the pottery being produced. Kilns used for firing red figure and black figure pottery, popular from the 6th century BCE to the 4th century BCE, typically operated at temperatures ranging from 800 to 1000 degrees Celsius. These temperatures were critical for achieving the desired color and finish of the glazes. The kilns were often equipped with pyrometric cones, which were small clay cones that melted at specific temperatures, allowing potters to gauge the heat within the kiln during firing. The placement of these cones was strategic, often positioned at various points within the kiln to provide a comprehensive overview of temperature distribution. Moreover, kiln designs evolved over time, with evidence suggesting that the introduction of updraft kilns around the 5th century BCE allowed for improved airflow and heat retention. These updraft kilns, which featured a design that directed flames upward through the ceramic pieces, were particularly effective in achieving the high temperatures necessary for fine pottery production. Archaeological excavations at sites such as Corinth and Athens have uncovered remnants of these advanced kilns, showcasing their complex construction and strategic placement within pottery workshops. In conclusion, the evolution of ancient Greek pottery kilns reflects a rich tapestry of construction techniques, maintenance practices, economic considerations, personnel roles, and technical specifications. Each aspect contributes to a broader understanding of the pottery production process, illuminating the skill and knowledge of ancient potters. The meticulous documentation of kiln temperatures and related practices, while often viewed as mundane, provides critical insights into the technical achievements of the time, ensuring that the legacy of ancient Greek ceramic art endures. The ongoing study of these kilns continues to reveal the intricate relationship between art, technology, and economy in the ancient world. The construction methods and materials utilized in the creation of ancient Greek pottery kilns exhibit a notable consistency across various regions and periods, reflecting the technical knowledge and resource availability of the time. Typically, kilns were constructed using locally sourced clay, which, when fired, provided the requisite durability and thermal resistance essential for high-temperature firings. The predominant clay types used included red clay and light-colored clay, both of which were abundant in the Mediterranean landscape. The earliest evidence of pottery kilns in Greece can be traced back to the Neolithic period, around 6500 BCE, with the advent of pottery production in the Aegean Sea region. By the time of the Mycenaean civilization, circa 1600 to 1100 BCE, kiln technology had advanced significantly. Archaeological findings from sites like Mycenae and Tiryns reveal large, beehive-shaped kilns built into the ground, which were capable of reaching high temperatures, necessary for fusing various clay bodies and glazes effectively. These kilns often featured a circular plan and were lined with refractory materials to withstand the intense heat generated during firing. One of the key developments in kiln construction was the introduction of the updraft kiln, which became prevalent in the 7th century BCE. This innovation allowed for more efficient heat distribution and better control over firing temperatures, which were essential for producing high-quality pottery, such as the black figure and red figure wares that characterized the Archaic and Classical periods, circa 700 to 323 BCE. The transition from the earlier downdraft kilns to updraft kilns marked a significant technological advancement, allowing artisans to produce more intricate and finely detailed pottery. The kilns themselves varied in size, typically ranging from small, single-chamber designs to larger, multi-chamber structures capable of firing numerous pots simultaneously. For instance, a standard updraft kiln could measure approximately 1.5 to 2 meters in height and 1 meter in diameter, providing sufficient space for several dozen vessels. A notable example of an ancient kiln can be found in the city of Corinth, where excavations have uncovered well-preserved remnants of a pottery workshop that operated in the 6th century BCE. These kilns featured vertical shafts that allowed smoke and hot air to circulate, significantly improving the efficiency of the firing process. Moreover, the materials used in kiln construction were carefully selected based on their thermal properties. The walls of kilns were often made from a mixture of clay and crushed stone or bricks, which provided added insulation and structural support. This combination not only enhanced the kiln's durability but also facilitated the creation of a stable firing environment. In regions like Attica, where fine clay was abundant, potters would often line their kilns with fine-grained clay for improved performance. In addition to the technical aspects of kiln construction, the firing process itself was a highly skilled art. Potters would typically use wood as fuel, which was strategically placed to create an even distribution of heat. The temperature inside the kiln could reach upwards of 1000 degrees Celsius, allowing for the transformation of clay into ceramic through a series of complex chemical reactions. The firing process could last anywhere from several hours to a full day, depending on the size of the kiln and the quantity of pottery being produced. Historical context also plays a critical role in understanding the evolution of kiln technology in ancient Greece. The 5th century BCE, often referred to as the Golden Age of Athens, saw a significant surge in the production of pottery, driven by both domestic needs and the burgeoning trade networks established throughout the Mediterranean. As Greek colonies flourished, the demand for pottery, ranging from everyday utilitarian vessels to elaborate ceremonial items, grew exponentially. This demand spurred innovation in kiln design and firing techniques, enabling potters to experiment with new forms and decorative styles. A prime example of this innovation can be seen in the pottery of the Panathenaic amphorae, large ceramic vessels awarded as prizes during the Panathenaic Games, which began in 566 BCE. The production of these amphorae required not only skilled craftsmanship but also advanced kiln technology to achieve the desired finish and durability. The kilns used for these specialized items were often larger and more sophisticated, tailored specifically for the unique requirements of mass production. In conclusion, the construction and operation of ancient Greek pottery kilns were marked by a remarkable degree of consistency and innovation, reflecting the potter's understanding of materials and processes over centuries. From the early beehive kilns of the Mycenaean period to the advanced updraft kilns of classical Greece, these structures played an essential role in the development of Greek pottery, influencing not only the aesthetics of the time but also the cultural and economic framework of ancient Greek society. The legacy of these kilns and the pottery they produced continues to be a subject of fascination for archaeologists and historians alike, providing invaluable insights into the technological prowess and artistic sensibilities of the ancient Greeks. The construction of ancient Greek pottery kilns is a subject that warrants meticulous examination due to its significance in the overall functionality and efficiency of ceramic production. The kilns, which were key to achieving the high temperatures necessary for transforming raw clay into durable pottery, were typically constructed from locally available materials. These materials included clay, mud brick, and in some cases, stone. The predominant method of construction, particularly in the 6th century BCE, involved the use of a circular or rectangular plan, with a domed roof designed to facilitate even heat distribution. The walls of these kilns were generally thick, measuring approximately 30 to 50 centimeters, which served to insulate the interior and maintain high temperatures. The firing chamber, where the pottery was placed, was often elevated to enhance airflow and heat retention. Archaeological evidence from sites such as Corinth and Athens indicates that kilns could reach temperatures between 800 to 1,200 degrees Celsius, a range sufficient for both earthenware and fine pottery production. The entrance to the kiln, which allowed for the loading and unloading of pottery, was typically a small, arched opening, measuring around 50 centimeters in height and 40 centimeters in width. This design not only provided access but also minimized heat loss during the firing process. The flue, or chimney, was another critical feature, allowing smoke and gases to escape while drawing in fresh air to feed the fire. These flues were often constructed at a height of 1 to 2 meters above the kiln's apex, ensuring adequate ventilation. Maintenance of these kilns was essential for their longevity and operational efficiency. The upkeep involved regular inspections for structural integrity and the replacement of worn or damaged parts. Evidence suggests that kiln operators, often skilled craftsmen themselves, would carry out routine cleaning of the flue and firing chamber after every use to remove ash and soot buildup. This process likely occurred over the course of several hours, using simple tools such as brushes made from twigs or reeds. Periodic repairs were also necessary, especially after prolonged use. The rebuilding of sections of the kiln, particularly in the firing chamber, was common, with records indicating that such maintenance could occur every few years depending on the intensity of use. In terms of labor, it is estimated that a typical kiln required a dedicated team of 3 to 5 workers for its operation and maintenance. Each worker had specific roles. One would be responsible for the preparation of clay, another for loading the kiln, while a third would tend to the fire. The financial implications of operating a pottery kiln in ancient Greece are documented through various inscriptions and financial records. For example, a fragmentary inscription from the Agora in Athens dated to the early 4th century BCE reveals that the cost of constructing a kiln could range from 100 to 300 drachmas, depending on size and materials used. The initial investment was substantial, but it was often recuperated through the sale of pottery. The average price of a high-quality amphora could be approximately 10 to 15 drachmas, indicating that a successful kiln operation could yield significant profits over time. Cost analysis of kiln operation extended to fuel expenses, predominantly wood, which was the primary source of heat for firing pottery. Estimates suggest that a single firing could consume between 500 to 1,000 kilograms of wood, depending on the kiln size and the desired temperature. The price of wood fluctuated based on availability, but records indicate a consistent cost of around 1 drachma per 50 kilograms. Consequently, fuel costs per firing could total between 10 to 20 drachmas. Documentation from the late 5th century BCE provides insights into the profitability of pottery production. One such record indicates that a successful pottery workshop, operating multiple kilns, could generate annual revenues exceeding 2,000 drachmas, with net profits after expenses averaging around 800 drachmas. This profitability was contingent upon factors such as market demand, the quality of the produced ware, and the efficiency of the kiln operations. Personnel involved in the operation of pottery kilns had clearly delineated roles, reflecting the organized nature of ancient Greek craftsmanship. The head potter, often referred to as the keramius, oversaw all kiln operations and was responsible for the overall production schedule. This individual was typically skilled in both pottery making and kiln management, ensuring that the firing process was conducted efficiently and effectively. The keramius would often train apprentices, who began their careers as laborers, performing menial tasks such as clay preparation and kiln loading. Beyond the keramius, other specialized roles included the thermoteris, responsible for monitoring kiln temperatures during firings. This position required a keen understanding of the firing process, as maintaining the correct temperature was crucial for the quality of the pottery produced. The thermoteris would use simple tools, such as clay cones or pyrometric devices, to gauge temperature, ensuring that the firing remained within the desired range. Additionally, laborers were employed to assist with the various stages of production, from clay extraction to the final glazing and finishing of the pottery. It is estimated that a kiln facility could employ anywhere from 10 to 20 individuals, depending on the scale of operations. Each worker's contribution was vital, as the success of the pottery depended not only on the kiln's efficiency but also on the collective effort of the entire team. Technical specifications of ancient Greek kilns reveal a remarkable understanding of materials and thermodynamics. The construction typically included a double-wall design, which enhanced insulation and reduced heat loss. The inner walls were often coated with a layer of clay mixed with organic materials, such as straw, to improve thermal efficiency. This technique, evidenced by chemical analyses of kiln remains, allowed potters to achieve the high temperatures necessary for vitrification of clay. Kilns varied in size and complexity, with some advanced designs featuring multiple chambers for different stages of firing. For instance, multi-chamber kilns, which emerged during the 4th century BCE, allowed potters to fire multiple batches simultaneously, significantly increasing production efficiency. These kilns, with dimensions reaching up to 3 meters in height and 2 meters in diameter, required precise engineering to ensure optimal airflow and temperature control. The firing process itself was meticulously timed, often lasting between 12 to 36 hours depending on the type of pottery being produced. Potters developed specific schedules for different ware types, with red figure pottery requiring a reduction phase to achieve its distinctive coloration. This phase was carefully monitored by the thermoterist, who adjusted the airflow based on visual cues and temperature readings. In conclusion, the evolution of ancient Greek pottery kilns encapsulates a profound interplay of materials science, labor organization, and economic considerations. The construction methods and materials, coupled with thorough maintenance procedures and detailed financial records, reflect a sophisticated understanding of the pottery production process. The personnel involved in this endeavor were integral to its success, each playing a critical role in ensuring that the artistic and functional demands of ancient Greek society were met. The technical specifications and operational practices documented in historical records provide a comprehensive overview of the kiln's role in the broader context of ancient Greek pottery, underscoring its significance as both a technological achievement and a cultural artifact. The construction methods and materials utilized in ancient Greek pottery kilns reveal a systematic approach to engineering that was dictated by both available resources and emerging technological standards. The most prevalent kiln type during the 6th century BCE was the updraft kiln, characterized by its vertical design, which facilitated the ascent of heat. These kilns were typically constructed from locally sourced clay bricks, which were fired at lower temperatures before being assembled into the kiln structure. The average dimensions of these kilns ranged from 1.5 to 2.5 meters in height, and the diameter of the fire chamber was approximately 1 meter. The inner lining of the kiln was often reinforced with a mixture of clay and grog, which is crushed fired pottery, to enhance heat retention. The layering of the construction materials was critical to the efficiency of the kiln, as it directly affected the distribution of heat. According to archaeological findings from a site in Corinth dated to around 500 BCE, kilns were often equipped with a flue system that allowed for better ventilation. The flue openings were typically 10 to 20 centimeters in diameter, strategically placed to optimize airflow and promote even firing. Maintenance procedures for these kilns were a crucial aspect of their operation, often dictated by the frequency of use and the intensity of firing. Regular inspections were necessary to ensure structural integrity, particularly focusing on the door seals and flue openings, which were prone to wear. The maintenance schedule varied, with extensive inspections occurring biannually, while minor repairs were conducted as needed. Historical records indicate that the clay used for repairs was often mixed with straw or other fibrous materials to enhance durability. The average lifespan of a kiln, assuming proper maintenance, was estimated to be around 10 to 15 years before significant reconstruction was required. Financial records pertaining to pottery kilns indicate a complex economic structure surrounding their operation. The costs associated with constructing and maintaining a kiln were substantial, often representing a significant investment for potters. In the early 5th century BCE, the average cost of constructing a small kiln was approximately 100 drachmas, a considerable sum given that a skilled potter might earn around 3 drachmas per day. These financial records also detail expenses related to fuel procurement, with wood being the primary source of heat. A detailed account from a pottery workshop in Athens from 450 BCE reveals expenditures of up to 20 drachmas per month for firewood alone. In terms of personnel and job descriptions, the operation of a pottery kiln involved a range of skilled laborers, each with defined roles. The master potter, often the owner of the workshop, oversaw the entire process, ensuring that the quality of the clay and the glazing materials met stringent standards. The master potter was typically supported by several assistants, who were responsible for tasks such as shaping the pottery, applying glazes, and managing the kiln during firing. An assistant potter, for example, would begin their apprenticeship at around the age of 14, gradually taking on more complex tasks over a period of 5 to 7 years. Typologically, the roles within the workshop were hierarchical. The kiln operator, a specialized position, was responsible for monitoring the kiln's temperature and ensuring that the firing process adhered to specific requirements. Records from a workshop in Ephesus in the late 4th century BCE highlight a kiln operator's hourly wage at 1 drachma, reflecting the skill level required for this pivotal role. This suggests a structured labor system, with clear differentiation in duties and compensation. Technical specifications of ancient Greek kilns further elucidate the sophistication of their design. Most kilns featured a domed structure, which not only provided efficient heat distribution but also facilitated the creation of a controlled atmosphere within the firing chamber. The interior of the kiln was typically lined with a refractory clay that could withstand temperatures exceeding 1000 degrees Celsius. Measurements taken from kiln remnants at various archaeological sites indicate that the firing temperature was carefully monitored, often recorded using simple thermometric devices made from clay. The firing cycles typically lasted between 12 to 24 hours, depending on the type of pottery being produced. For instance, fine red figure pottery required higher temperatures and longer firing times compared to utilitarian wares. A standard firing cycle began with a gradual increase in temperature, reaching approximately 600 degrees Celsius over the first 6 hours, followed by a peak temperature of up to 1000 degrees Celsius. This was then followed by a controlled cooling period, lasting an additional 6 to 8 hours, to prevent thermal shock that could result in cracking. Moreover, the kilns often included provisions for multiple firing levels, allowing potters to maximize the use of space. Evidence from a kiln excavated in Rhodes dates back to the 3rd century BCE and demonstrates 3 distinct firing chambers, each capable of accommodating a different type of pottery. This multi-tiered design not only increased production efficiency but also indicated an advanced understanding of heat management within the kiln environment. In summary, The evolution of ancient Greek pottery kilns encapsulates a blend of technological ingenuity and cultural significance. The meticulous construction methods, rigorous maintenance procedures, detailed financial records, structured labor hierarchy, and precise technical specifications underscore the complexity of this ancient craft. From the careful selection of materials to the nuanced management of firing processes, these kilns serve not merely as functional tools but as integral components of a vibrant cultural tradition that has left a lasting legacy in the annals of human history. The construction methods and materials utilized in ancient Greek pottery kilns reveal a systematic approach to engineering that was dictated by both available resources and emerging technological standards. The most prevalent kiln type during the 6th century BCE was the updraft kiln, characterized by its vertical design, which facilitated the ascent of heat. These kilns were typically constructed from locally sourced clay bricks, which were fired at lower temperatures before being assembled into durable structures. The updraft kilns were often built with a circular or square base that narrowed toward the top, creating a tapered shape that enhanced the efficiency of heat circulation within the chamber. This design allowed the hot air generated by the fire to rise through the stacked pottery, ensuring even heat distribution and effective firing. The walls of these kilns could reach up to 1 meter thick, providing insulation that retained heat for extended periods, which was crucial for achieving the high temperatures necessary for vitrifying clay, a process that transforms clay into a glass-like state, enhancing the durability and aesthetic qualities of pottery. Specific evidence of these kilns can be found in archaeological sites across Greece, such as the ancient city of Corinth, where excavations have revealed remnants of kilns dating back to the late 6th century BCE. These kilns were often situated near workshops, facilitating the efficient transportation of raw materials and finished products. For example, the workshop of the famous potter Exekias, known for his exquisite black figure pottery, likely employed such kilns to achieve the high firing temperatures needed for his intricate designs. In addition to the updraft kiln, another significant type of kiln used during this period was the clamp kiln, which was constructed directly on the ground and featured a series of stacked pottery pieces arranged in clusters. This method, prevalent in the 5th century BCE, allowed for the efficient use of space and fuel. The clamp kiln operated by building a temporary structure around the pottery, with fuel such as wood or olive pits placed between the pots. Once ignited, the fire would radiate heat outward, with the smoke and hot air circulating around the pots. This method, while less efficient than the updraft design in terms of heat retention, was favored for its simplicity and the ease of construction. Historically, the development of kiln technology in Greece can be traced back to the Minoan civilization, circa 2000 to 1450 BCE, where the earliest evidence of pottery firing emerged. However, it was during the geometric period, circa 900 to 700 BCE, that the Greeks began refining their kiln designs, leading to the innovations seen in the 6th century. The transition from open fires to more sophisticated kiln designs marked a significant technological advancement, as potters learned to control the firing process more precisely, resulting in improved quality and consistency of pottery. One of the most significant case studies illustrating the evolution of kiln technology is the discovery of the pottery workshop at the site of Panathenaic Agora in Athens, which dates to around 500 BCE. Here, archaeologists uncovered multiple kilns, each representing varying stages of technological advancement. The presence of both updraft and clamp kilns within the same site indicates the coexistence of traditional and innovative firing methods, reflecting a transitional phase in pottery production techniques. The analysis of pottery shards from this site revealed a diverse range of styles, including black figure and red figure pottery, both of which required specific firing techniques to achieve their characteristic appearances. Furthermore, the chemical composition of the clay used in these kilns played a crucial role in the firing process. Potters often selected clay with specific mineral content, such as kaolinite and illite, which contributed to the final color and texture of the fired pottery. For instance, the inclusion of iron oxide within the clay led to the rich, natural red hues found in many Greek ceramics, while the use of slip, a liquid mixture of clay and water, allowed artisans to create intricate designs and patterns on the surface of their wares. In terms of measurements, the temperature range for firing pottery in these kilns typically fell between 800 degrees Celsius to 1000 degrees Celsius. This temperature was sufficient to cause the clay particles to fuse together, creating a solid and impervious body that could withstand daily use. The ability to reach and maintain such temperatures was a testament to the skill and knowledge of ancient Greek potters, who often experimented with different types of wood and firing techniques to achieve optimal results. In summary, the construction methods and materials utilized in ancient Greek pottery kilns were not merely practical but were also reflective of the cultural and technological advancements of the time. The evolution from simple open firing methods to complex kiln designs marks a significant chapter in the history of pottery, illustrating the interplay between art and science in ancient Greece. The legacy of these innovations continues to influence ceramic practices worldwide, underscoring the enduring impact of Greek pottery on the art and craft of ceramics today. The construction methods and materials utilized in ancient Greek pottery kilns were characterized by a series of systematic and practical approaches that evolved over centuries. The earliest kilns, dating back to the geometric period, circa 900 to 700 BCE, were often simple pit kilns, which were dug into the ground and used readily available local clay and stones. By the Archaic period, circa 700 to 480 BCE, however, advances in technology and increasing demands for pottery led to more sophisticated kiln designs. The typical structure of a Greek kiln during the Classical period, circa 480 to 323 BCE, was often circular or rectangular in shape, with the interior lined with a layer of clay, which could withstand high temperatures. Most kilns were built using a combination of clay, limestone, and other local materials. The use of refractory clay, which could withstand higher temperatures without deforming, became prevalent. For instance, in the 5th century BCE, kilns were often constructed with walls measuring 30 to 50 centimeters in thickness to ensure structural integrity and thermal insulation. The design of the kiln itself underwent modifications, including the introduction of flue systems to improve airflow and enhance combustion efficiency. By the Hellenistic period, circa 323 to 30 BCE, kilns featured more intricate designs, including the use of archways and domed ceilings. The dimensions of these kilns varied significantly. A typical kiln might measure approximately 1.5 meters in height and 2 to 3 meters in diameter, with the firing chamber often large enough to accommodate several hundred vessels at once. Maintenance procedures were critical to the longevity and efficiency of ancient Greek kilns. Regular inspections were conducted to check for structural integrity, with particular attention paid to the interior lining, which could become damaged from repeated thermal cycling. Maintenance typically involved repairing cracks and reinforcing walls with additional layers of clay as needed. The periodic cleaning of the kiln was also essential. Ash and residue buildup could hinder airflow and affect firing temperatures. This cleaning process generally involved the removal of any remnants of previous firings and the scraping of the interior surfaces to ensure optimal performance. Financial records from the era indicate that the costs associated with kiln construction and maintenance were significant. The expenditure for constructing a typical kiln could range from 100 to 200 drachmas, depending on the complexity of the design and the materials used. Additionally, the labor costs incurred in the construction and maintenance of these kilns were substantial. Skilled laborers, such as potters and kiln builders, might charge upwards of 2 to 5 drachmas per day, a considerable sum given the average daily wage for unskilled laborers was approximately 1 drachma. In terms of personnel, the operation of a pottery kiln necessitated a range of job descriptions and responsibilities. The primary role was that of the master potter, who oversaw all aspects of pottery production, from the initial design to the final glazing. Master potters were typically experienced artisans who had undergone extensive training, often beginning their apprenticeships as young as 12 years old. They were responsible for determining kiln temperatures, which could reach up to 1000 degrees Celsius, and for adjusting the fuel supply accordingly. Supporting the master potter were several other key personnel. The assistant potter, often an apprentice, was tasked with preparing the clay and assisting in the shaping of vessels. This role required familiarity with various clay types, as different compositions could yield significantly different results in terms of durability and aesthetics. Additionally, fuel gatherers were employed to source and transport wood or other combustible materials, which were essential for achieving the high temperatures required for successful firings. Technical specifications of the kilns included detailed measurements of the firing chamber and flue systems. The firing chamber itself was often cylindrical, with a height-to-diameter ratio of approximately 2 to 1, facilitating better airflow and heat distribution. The flues, which were essential for venting smoke and gases, typically measured around 20 centimeters in diameter and were strategically placed to optimize the draft. The temperature within the kiln was monitored using simple thermometric devices, such as pyrometric cones, which would melt at specific temperatures, providing a visual cue for the potters. In summary, the evolution of ancient Greek pottery kiln construction, maintenance, financial aspects, personnel roles, and technical specifications reflects a meticulous approach to ceramic production. The interplay of materials, design, and labor created a framework that allowed for the flourishing of Greek pottery, which remains a subject of study and admiration in the contemporary world. The interplay of economics, craftsmanship, and technical knowledge contributed to the enduring legacy of ancient Greek ceramics, which continues to influence modern practices and techniques in pottery today. The construction methods and materials utilized in ancient Greek pottery kilns were characterized by a series of systematic and practical approaches that evolved over centuries. The earliest kilns, dating back to the geometric period, circa 900 to 700 BCE, were often simple pit kilns, which were dug into the ground and used readily available local clay and stones. These rudimentary kilns were typically about 1 to 2 meters in diameter and could achieve temperatures between 600 to 800 degrees Celsius, sufficient for firing basic pottery forms. By the Archaic period, circa 700 to 480 BCE, however, advances in technology and increasing demands for pottery led to more sophisticated structures. The development of updraft kilns, which had a chimney or flue to help regulate airflow and control temperature, marked a significant evolution in pottery production. These kilns were often built with a rectangular or circular layout and could reach higher temperatures of about 900 to 1000 degrees Celsius, allowing for finer ceramics and a broader range of decorative techniques, including the black figure and red figure styles that would become hallmarks of Greek pottery. One notable example from the Archaic period is the kiln excavated at the site of Athens, which dates to the 6th century BCE. This kiln was built of clay bricks and had a well-defined firing chamber that measured approximately 2 meters in length and 1 meter in width. The design allowed for multiple pots to be fired simultaneously, maximizing efficiency. Archaeological evidence suggests that the Greeks began using kiln furniture, such as shelves and supports made of clay, to organize pottery within the kiln, which facilitated better heat distribution and reduced the likelihood of pieces sticking together during firing. The Classical period, circa 480 to 323 BCE, saw even further innovations in kiln design, with the introduction of more complex multi-chamber kilns. These kilns could contain several firing chambers, each capable of being fired independently. They allowed potters to experiment with different firing techniques and atmospheres, resulting in a wider variety of finishes and surface treatments. For example, the use of a reducing atmosphere, achieved by controlling the airflow during firing, could produce a metallic sheen on certain clay bodies, enhancing the visual appeal of the pottery. One particularly famous kiln from this period is the one associated with the potter Euphronios, known for his exquisite red figure vases. Excavated in the late 19th century from a site near Rome, the kiln was found to have a large central chamber capable of holding dozens of pieces. The careful arrangement of pottery within the kiln allowed Euphronios to achieve the delicate colors and intricate details for which his work is celebrated. His vases often depicted scenes from mythology and daily life, showcasing the skill and artistry of Greek potters. By the Hellenistic period, circa 323 to 31 BCE, the demand for pottery had grown even more, leading to the development of industrial-scale kilns. These large-scale kilns, sometimes measuring up to 3 meters in height and 4 meters in width, were often built on the outskirts of urban centers to accommodate the increased production demands. They featured advanced ventilation systems and could achieve temperatures exceeding 1000 degrees Celsius, which permitted the firing of more complex ceramic forms, including large amphorae used for transporting liquids such as wine and oil. The use of slip, a liquid mixture of clay and water, also became more prevalent during this period. Potters would apply slip to their vessels before firing to create a smoother surface for painting and to enhance the pottery's aesthetic appeal. The slip could be colored using various mineral additives, allowing for a broader palette in decorative styles. For instance, the famous amphorae from the island of Rhodes often featured vibrant colors, showcasing the artistic innovations of this time. To understand the impact of kiln technology on pottery production, one must also consider the socio-economic context of ancient Greece. The growth of city-states, increased trade networks, and the rise of a wealthy merchant class created a fertile environment for artistic endeavors. Pottery became not only functional but also a symbol of status, leading to an increase in specialized potters who honed their craft and developed distinct styles. This specialization contributed to the regional diversity in pottery styles, as evidenced by the differences between Athenian ceramics and those produced in Corinth or Sparta. Furthermore, the study of ancient Greek kilns has benefited from modern archaeological techniques, including thermoluminescence dating and chemical analysis of ceramic materials. These methods have provided insight into the firing temperatures and conditions of ancient kilns, furthering our understanding of the technological advancements over time. For instance, thermoluminescence dating has revealed that some kilns operated at significantly higher temperatures than previously thought, indicating a mastery of materials and techniques that allowed Greek potters to achieve remarkable artistic standards. In conclusion, the evolution of pottery kilns in ancient Greece reflects a complex interplay of technological innovation, artistic expression, and socio-economic factors. From simple pit kilns of the geometric period to the elaborate multi-chamber kilns of the Hellenistic era, the development of kiln technology significantly impacted the quality and variety of pottery produced. These advancements not only allowed potters to create intricate artworks but also facilitated the growth of an industry that would leave a lasting legacy in the annals of art history. As we continue to explore and excavate these ancient sites, we gain a deeper appreciation for the skill, ingenuity, and cultural significance of Greek pottery and its production methods. The intricate tapestry of ancient Greek pottery kiln temperature records offers a unique lens through which we can explore not only the technical advancements in pottery but also the socio-cultural dynamics of the era. As we delve into the next segments of this exhaustive historical discourse, we will focus on various aspects including regional variations and comparisons, the evolution over different time periods, the bureaucratic regulations and laws governing pottery production, supply chain and logistics intricacies, and the methodologies employed in record keeping. Regional variations and comparisons. The geographical expanse of ancient Greece was not merely a backdrop for artistic endeavors but a significant factor influencing the temperature records of pottery kilns. Different regions of Greece developed distinct pottery styles and techniques, which in turn dictated their kiln operations. For instance, the famed red figure pottery of Athens, produced between the 6th and 4th centuries BCE, often required more precise temperature control to achieve the desired effects of color and detail. Archaeological evidence suggests that Athenian potters utilized kilns capable of reaching temperatures upwards of 1000 degrees Celsius, a feat achieved through meticulous management of fuel sources, predominantly wood and olive pits. In contrast, the Corinthian pottery tradition, which flourished contemporaneously, exhibited a preference for black figure techniques. The kilns used in Corinth were often built with slightly different materials, such as a unique clay mix that could withstand lower operational temperatures, averaging around 800 to 900 degrees Celsius. This regional variance not only highlights the technological innovations of the respective areas but also underscores the socio-economic factors influencing pottery production, such as local availability of resources and trade networks. Moreover, the island of Crete presented yet another dimension to this discussion. The Minoan civilization, which predated classical Greece, showcased advanced kiln technology that has led scholars to believe that their kilns operated at variable temperatures depending on the type of pottery being produced. This adaptability indicates a sophisticated understanding of material properties that would later influence mainland Greek practices. The remnants of Minoan kilns, often found near archaeological sites, reveal structural designs aimed at optimizing airflow, thus allowing for enhanced temperature regulation. When comparing these regional practices, it becomes apparent that the evolution of kiln technology was not merely a linear progression but rather a complex interplay of local traditions, environmental factors, and resource availability. The diverse approaches to temperature management across regions underscore a rich tapestry of innovation that characterized the era. Evolution over different time periods. The chronological evolution of kiln temperature records in ancient Greece reveals a gradual yet profound transformation in pottery production techniques. The early geometric period, circa 900 to 700 BCE, was characterized by relatively simple kilns that operated at lower temperatures, often around 600 to 700 degrees Celsius. The pottery produced during this time was primarily functional, serving everyday purposes with little emphasis on decorative quality. The kilns themselves were rudimentary in design, often consisting of open fires or pit kilns, which allowed for limited control over temperature and atmosphere. As we transition into the Archaic period, circa 700 to 480 BCE, we witness a significant advancement in kiln technology and pottery styles. The introduction of the potters will revolutionize the production process, resulting in more uniform shapes and sizes. The kilns of this period began to incorporate more sophisticated designs, such as updraft kilns that allowed for higher temperatures and better ventilation. This innovation enabled potters to experiment with different clay bodies and firing techniques, leading to the development of the iconic black figure and red figure pottery styles. The Classical period, circa 480 to 323 BCE, marked the zenith of Greek pottery, characterized by both artistic excellence and technological sophistication. Kiln temperatures reached unprecedented levels, often exceeding 1000 degrees Celsius, allowing for intricate detailing and the use of slip and glaze applications. The meticulous record-keeping of kiln temperatures during this period indicates a growing awareness of the relationship between firing conditions and artistic outcomes. Potters meticulously documented their firing cycles, noting the duration and temperature variations that yielded optimal results. The Hellenistic period, circa 323 to 30 BCE, introduced further innovations, including the advent of large-scale production facilities. The emergence of bureaucratic oversight led to standardized practices in kiln operation, necessitating more rigorous temperature monitoring. This period also saw the incorporation of foreign influences, as trade routes expanded and new materials and techniques were introduced to Greek potters. The interplay of local traditions with external innovations created a dynamic environment for pottery production, wherein kiln temperature records became a vital component of quality control. Bureaucratic regulations and laws. The increasing complexity of pottery production during the Hellenistic period necessitated the establishment of bureaucratic regulations and laws governing kiln operations. As pottery became a significant economic commodity, the need for standardized practices emerged to ensure quality and consistency. Local governments and guilds began to impose regulations that dictated kiln construction, fuel usage, and firing procedures. Records indicate that Athens, as a major center of pottery production, implemented laws concerning the types of clay that could be used, the construction of kilns, and even the types of fuels permissible for firing. These regulations aimed to maintain the quality of Athenian pottery, ensuring that it remained competitive in both domestic and foreign markets. Violations of these regulations were met with penalties, underscoring the importance of adherence to established standards. Additionally, guilds formed among potters, fostering a sense of community while also creating a structured environment for the sharing of knowledge regarding kiln operation and temperature management. These guilds often maintained detailed records of their practices, contributing to a collective understanding of optimal firing techniques. The bureaucratic oversight not only standardized practices but also facilitated the dissemination of technological advancements across regions, further influencing kiln temperature records. Supply chain and logistics. The production of pottery in ancient Greece cannot be fully understood without considering the intricate supply chains and logistics involved in the process. The acquisition of raw materials, such as clay, glazes, and fuels, played a critical role in determining the operational efficiency of kilns and the final quality of the pottery produced. The sourcing of clay, for instance, was a labor-intensive endeavor. Potters had to identify suitable clay deposits, often requiring extensive geological knowledge of their local environment. Different regions in Greece offered varying clay types, each with distinct properties. The transportation of these materials to pottery workshops posed additional logistical challenges. Clay was typically transported in large containers, and the process of extracting and processing clay was not only time-consuming but also required meticulous attention to detail to ensure the right consistency and moisture content. Fuel logistics also played a significant role in kiln operation. Wood and olive pits were the primary fuel sources for kilns, but the procurement of these materials necessitated careful planning and management. The demand for fuel often fluctuated based on the scale of production, requiring potters to establish reliable supply chains. Historical records suggest that certain regions developed trade networks specifically for the exchange of raw materials, thus influencing local kiln operations and temperature management practices. Moreover, the positioning of kilns within pottery workshops was strategically planned to facilitate efficient workflows. Potters often organized their workshops to minimize the distance between raw material storage, the throwing area, and the kilns. This logistical arrangement optimized the production process and allowed for better control over firing schedules and temperature monitoring. Record-keeping methods. The methodologies employed for record-keeping in ancient Greek pottery production reveal a fascinating aspect of the industry. The meticulous documentation of kiln temperatures, firing cycles, and material sources was crucial for ensuring quality and consistency in pottery production. Potters utilized various methods for record-keeping, often depending on the resources available and the specific practices of their region. One common method involved the use of clay tablets or inscribed pottery pieces, where potters would note the temperature ranges achieved during specific firings. These records served as invaluable references for future productions, allowing potters to replicate successful techniques. Additionally, many potters employed mnemonic devices, such as specific symbols or codes, to denote particular firing conditions or material sources. In some regions, the establishment of pottery workshops led to the development of more formalized record-keeping practices. Workshops often maintain detailed logs of kiln operations, including temperature settings, duration of firings, and the types of pottery produced. This information was critical for quality assurance, particularly for large-scale productions where consistency was paramount. The evolution of record-keeping methods also mirrored broader societal changes. As pottery production became increasingly commercialized, the need for accurate and comprehensive records grew. This shift prompted the introduction of more structured documentation practices, which were often overseen by guilds or local authorities. These organizations played a key role in standardizing record-keeping practices, ensuring that potters adhered to established guidelines. In conclusion, the expansive history of kiln temperature records in ancient Greek pottery encapsulates a multitude of factors, from regional variations and bureaucratic regulations to the intricacies of supply chains and record-keeping methodologies. As we continue to unravel the complex narrative of this evolution, it becomes clear that the interplay between technology, culture, and economy shaped the development of pottery practices in profound and enduring ways. The evolution of kiln temperature management not only reflects advancements in craftsmanship but also serves as a testament to the rich tapestry of human ingenuity that characterized ancient Greece. ### The boring evolution of ancient Greek pottery kiln temperature records. ### Regional variations and comparisons. The study of kiln temperatures in ancient Greece is not merely a matter of scientific inquiry but also a reflection of the cultural and geographical diversity that characterized the ancient Greek world. Each region, from Attica to Corinth and from Aegean islands to the Peloponnese, exhibited unique characteristics that influenced kiln construction, firing methods, and consequently, temperature recording practices. For instance, in the region of Attica, the production of pottery was closely linked to the availability of specific clay types found in the local soil. The Athenian potters often employed fine, high-plasticity clays that required precise temperature management during the firing process. This necessity led to the development of sophisticated methods for monitoring and documenting kiln temperatures, which included the use of thermoluminescence dating to ascertain the firing temperatures of pottery already excavated. Conversely, in Corinth, the presence of more coarse and gritty clay types resulted in different firing techniques. Corinthian potters often used lower firing temperatures compared to their Athenian counterparts, which necessitated an entirely different approach to temperature recording. The regional variations in materials and techniques led to distinct records of kiln temperatures, reflecting the localized practices of potters. Moreover, these regional differences were not static. They evolved over time, influenced by trade, cultural exchanges, and technological advancements. The introduction of new kiln designs, such as the updraft kiln versus the downdraft kiln, showcased how neighboring regions influenced each other. For example, the incursion of pottery styles from the Aegean Islands into mainland Greece prompted potters to adapt their firing techniques, leading to notable shifts in temperature records as they embraced new methods. ###evolution over different time periods. The chronological evolution of kiln temperature records provides a fascinating lens through which to view the advancements in both pottery techniques and recording practices over the centuries. From the geometric period, c. 900 to 700 BC, through the classical period, c. 500 to 323 BC, and into the Hellenistic period, c. 323 to 30 BC, significant changes can be observed in both the complexity of designs and the sophistication of firing techniques. During the geometric period, pottery was often simple in form and decoration, with straightforward firing methods that did not require precise temperature control. As such, the temperature records from this time are sparse and rudimentary, likely relying on anecdotal evidence from potters who would gauge the firing process through experience rather than empirical data. Moving into the Archaic period, c. 700 to 480 BC, the emergence of black figure and later red figure techniques necessitated greater control over kiln temperatures to achieve the desired aesthetic effects. This period saw the introduction of more advanced kilns, including the use of pyrometric cones, which allowed for more accurate temperature assessments. The records from this period began to reflect an increasing understanding of the chemical properties of clay and glazes, as potters began documenting their processes more rigorously. By the classical period, the complexity of pottery had reached new heights, with potters experimenting with multiple firing stages to achieve intricate glazes and finishes. The temperature records from this time period are notably more detailed, often including specific references to the types of clays used, the duration of firings, and the temperatures reached. The meticulous documentation of these factors was likely driven by both competition among potters and a burgeoning market for high-quality ceramics. In the Hellenistic period, the spread of Greek culture across vast territories following the conquests of Alexander the Great brought about an exchange of techniques and materials that further influenced kiln practices. The temperature records from this era reflect a synthesis of regional styles and technologies, showcasing an ever-evolving understanding of the thermal properties of different clays and glazes. ###bureaucratic regulations and laws. An often overlooked aspect of ancient Greek pottery production is the bureaucratic framework that underpinned the industry. Local governments and city-states established regulations regarding the production of pottery, which, in turn, influenced how kiln temperatures were recorded and managed. For example, in Athens, The agora served not only as a marketplace but also as a regulatory center where potters were required to adhere to specific standards concerning the quality and safety of their wares. These regulations often extended to the firing process, as substandard pottery could lead to legal repercussions, including fines or damage to a potter's reputation. Consequently, meticulous record-keeping became an essential practice, with potters documenting firing temperatures to demonstrate compliance with local standards. Moreover, the role of guilds in the pottery industry cannot be understated. These associations of potters often established their own internal regulations, which included guidelines on temperature management during firing. This self-regulation contributed to a culture of accountability, where potters were incentivized to maintain accurate records of their kiln temperatures to ensure the quality of their products and uphold the guild's reputation. Bureaucratic oversight extended beyond individual potters to encompass the broader economic implications of pottery production. For instance, in the wake of increased demand for pottery exports, some city-states instituted regulations concerning kiln emissions and environmental impacts, leading to further documentation of temperature management practices. These regulations underscored the intersection of craftsmanship and governance, highlighting how pottery production was not merely an artistic endeavor but also a matter of civic responsibility. ###### Supply chain and logistics. The production of pottery in ancient Greece was a highly interconnected process that involved an intricate supply chain encompassing the sourcing of materials, the firing of goods, and the distribution of finished products. Each aspect of this supply chain had implications for kiln temperature records, as variations in material availability and transport logistics influenced firing practices. The primary material for pottery production, clay, was often sourced from local deposits, yet the quality of clay could vary significantly between regions. As potters sought to create unique wares that appealed to different markets, they sometimes resorted to importing clay from distant locales. This practice necessitated careful temperature management, as different clay types exhibited varying thermal properties. Consequently, potters began to document the temperatures used for different clay sources, creating a database of sorts that would inform future production runs. Additionally, the logistics of transporting goods to market played a crucial role in how pottery was produced and fired. The increased demand for pottery in markets such as Athens and Corinth led to the establishment of elaborate trade networks, allowing for the swift movement of both raw materials and finished products. However, the constraints of transportation methods meant that potters had to be adaptable in their firing techniques. Records from this period often include notes on how transport times influenced firing schedules, with potters adjusting their practices to accommodate delays or fluctuations in demand. Furthermore, the establishment of storage facilities and workshops near kilns facilitated a more efficient supply chain. The proximity of these facilities meant that potters could monitor their firing processes more closely, leading to more accurate temperature records. This logistical advantage allowed for experimentation with different firing techniques, contributing to the evolution of pottery styles and the refinement of temperature management practices. ##### Record-keeping methods. The methods employed by ancient Greek potters to record kiln temperatures were as varied and complex as the pottery itself. While the existence of formalized record-keeping systems akin to modern scientific practices is not well documented, archaeological evidence suggests that potters utilized a range of informal methods to monitor and document their firing processes. One of the most significant methods of record-keeping involved the use of inscribed markers within kiln structures. Some kilns featured markings that indicated specific temperature thresholds or firing stages, allowing potters to reference past experiences when firing new batches. These inscriptions served as a form of institutional memory, providing invaluable insights into the firing techniques that had proven successful or unsuccessful in the past. In addition to physical markers, oral traditions played a crucial role in the transmission of knowledge among potters. Experienced craftsmen would often pass down their methods for recording temperatures through apprenticeships, thereby ensuring that the nuances of kiln management were preserved across generations. This reliance on oral history highlights the communal aspect of pottery production, where knowledge was shared and refined within tightly knit communities. Furthermore, the advent of written records during the later periods of ancient Greek history signaled a shift towards more formalized documentation practices. The introduction of papyrus and parchment allowed potters to maintain written logs detailing their firing temperatures, clay types, and other pertinent information. These records, while not universally preserved, provide a tantalizing glimpse into the meticulous nature of pottery production during this time. In conclusion, the tedious history of ancient Greek pottery kiln temperature records is an intricate tapestry woven from regional variations, chronological evolution, bureaucratic regulations, supply chain complexities, and diverse record-keeping methods. Each facet of this history contributes to a deeper understanding of the artistry and craftsmanship that defined ancient Greek pottery, revealing a world where even the most mundane aspects of production were imbued with cultural significance and historical importance. Part 8: Regional Variations and Comparisons. The study of ancient Greek pottery kiln temperature records reveals a fascinating tapestry of regional variations that reflect not only the geographical diversity of the Hellenic world but also the socio-political and economic nuances that influenced pottery production. In an era where information dissemination was limited and communication often fraught with the complexities of local dialects and customs, the temperature regimes of kilns varied significantly from one region to another. In the celebrated pottery workshops of Athens, for instance, kiln temperatures tended to be higher, frequently reaching upwards of 1050 degrees Celsius, especially during the production of the iconic black figure and red figure pottery. This elevated temperature facilitated the complex chemical reactions necessary for achieving the rich, glossy finishes that characterized Athenian wares. In contrast, the pottery of Corinth, while also esteemed, typically operated at slightly lower temperatures, averaging around 950 degrees Celsius. The difference in firing techniques can be attributed to both the availability of local clay types and the specific aesthetic preferences of the respective markets. The regional distinctions extend beyond mere temperature differences. The architectural designs of the kilns themselves varied considerably. Athenian kilns often featured sophisticated multi-chamber designs, which allowed for better heat distribution and more efficient firing cycles. In contrast, the simpler, single-chamber kilns found in regions such as Boeotia reflected a more rudimentary approach, which, while effective for local production, did not allow for the same level of refinement seen in Athenian pottery. Moreover, the geographical distribution of resources played a crucial role in shaping these regional practices. Areas rich in natural resources, such as the abundant clay deposits near the island of Crete, often produced distinctive pottery styles that necessitated specific firing techniques tailored to the properties of the local materials. These nuances further underscore the complexity of kiln temperature records as they relate to the broader socio-economic and environmental contexts of ancient Greek pottery production. Part 9: Evolution over different time periods. The evolution of kiln temperature records in ancient Greek pottery must also be viewed through the lens of time, as various periods from the geometric to the Hellenistic era exhibited distinct technological advancements and shifts in aesthetic preferences that influenced firing practices. During the early geometric period, circa 900 to 700 BCE, pottery was characterized by simple shapes and rudimentary decoration, necessitating lower firing temperatures, typically around 800 degrees Celsius. The kilns of this time, often pit or bonfire types, were limited in their ability to maintain high temperatures over extended periods. As techniques advanced, particularly with the advent of the Orientalizing period, circa 700 to 600 BCE, potters began experimenting with more intricate designs and improved firing methods, leading to a gradual increase in kiln temperatures. The transition into the Archaic period, circa 600 to 480 BCE, marked a significant turning point in kiln technology and temperature records. The introduction of the potters will allowed for more uniform shapes, while innovations in kiln construction facilitated higher firing temperatures. By the Classical period, circa 480 to 323 BCE, the refinement of both aesthetic techniques and kiln design resulted in temperatures reaching upwards of 1000 degrees Celsius, enabling the creation of the famed red figure pottery. The Hellenistic period, circa 323 to 31 BCE, witnessed further innovations, as the demand for more elaborate and diverse pottery styles necessitated even greater control over kiln operations. The introduction of advanced fuel sources and better insulation materials allowed for sustained high-temperature firings, with records indicating temperatures exceeding 1100 degrees Celsius in some workshops. This era not only showcased the technical prowess of potters but also reflected broader changes in trade and cultural exchange across the Mediterranean, as influences from Egypt and the Near East began to permeate Greek pottery production. Part 10: Bureaucratic Regulations and Laws. The intricate framework of bureaucratic regulations and laws governing pottery production in ancient Greece also warrants examination, particularly as it pertains to kiln operation and temperature management. The centralization of trade and the emergence of city-state governance systems led to the implementation of various legal codes aimed at regulating the production and sale of pottery. In Athens, for instance, city officials established strict regulations concerning the quality of pottery produced, which included stipulations regarding firing practices. Potters were often required to register their kilns with local authorities, who would conduct periodic inspections to ensure compliance with established temperature standards. Failure to adhere to these regulations could result in fines or, in more egregious cases, the revocation of operating licenses. These bureaucratic measures were not merely punitive but also served an educational purpose, as they aimed to improve the overall quality of pottery produced within the city. Workshops were encouraged to maintain meticulous records of kiln temperatures, firing durations, and the types of clay used in production. Such documentation would allow city officials to assess the quality of wares entering the marketplace and facilitate the enforcement of regulations. Additionally, these laws often intersected with religious practices, as certain pottery forms were dedicated to specific deities. The production of sacred vessels for temples was subject to even stricter oversight, with priests and civic authorities collaborating to ensure that the materials and firing techniques met the divine standards expected by the gods. This intersection of governance, trade, and religion highlights the multifaceted nature of ancient pottery production and its regulatory environment. Part 11: Supply Chain and Logistics. The complex supply chain and logistics involved in ancient Greek pottery production also played a pivotal role in influencing kiln temperature records. The journey from raw material extraction to finished product was fraught with challenges that required careful planning and coordination among various stakeholders. The procurement of clay, for instance, was not simply a matter of gathering local resources. Potters often engaged in intricate trade networks, sourcing specialized clays from distant regions. The transport of these materials necessitated a meticulous approach to logistics, as the physical properties of clay could vary significantly from one location to another, affecting the firing temperature required for optimal results. Potters had to be acutely aware of these variations to ensure the quality of their finished products. Once the clay was secured, the next phase involved the preparation and shaping of the pottery. This process required a considerable investment of time and labor, as the clay had to be carefully kneaded and wedged to eliminate air pockets before being shaped on the potter's wheel. The drying phase was equally critical, as the moisture content of the pottery affected how it would respond to heat during firing. Potters often relied on empirical knowledge passed down through generations to determine the optimal drying conditions, which could vary based on local climate and humidity levels. The logistics of kiln operation itself also required careful planning. The choice of fuel, whether wood, charcoal, or more advanced materials, was paramount, as different fuels produced varying temperatures and combustion characteristics. The procurement of fuel sources often involved an extensive supply chain, as potters needed to ensure a steady and reliable supply to maintain their kiln operations. The transportation of these materials, often over long distances, added another layer of complexity to the overall production process. Moreover, the distribution of finished pottery demanded its own logistical considerations. Once completed, pottery was often transported to local markets or exported to other city-states and regions. The fragility of pottery necessitated careful packing and handling, while the market demand influenced production rates and firing schedules. Potters often kept meticulous records of their sales and distributions, allowing them to adapt their production strategies based on market trends and consumer preferences. Part 12: Record-Keeping Methods. The meticulous record-keeping methods employed by ancient Greek potters provide invaluable insights into the operational aspects of kiln temperature management. Despite the lack of modern technological means, potters developed sophisticated systems to document their firing practices, clay types, and production outcomes. One prevalent method involved the use of clay tablets, which served as an early form of documentation. Potters would inscribe details of their kiln operations, including temperature readings, firing times, and the types of wares produced, onto these tablets. While the preservation of such records is sporadic, archaeological findings have revealed fragments that offer glimpses into the meticulous nature of these records. Additionally, oral traditions played a significant role in the transmission of knowledge related to kiln operations. Experienced potters often shared their insights with apprentices, passing down critical information on temperature management and firing techniques through word of mouth. This generational transfer of knowledge underscores the importance of practical experience in the pottery-making process. In conjunction with these methods, potters often utilized visual cues during the firing process. The color changes of the clay and glazes at various temperature thresholds served as indicators for potters to gauge when to adjust their kiln operations. The development of standardized color charts, although rudimentary by modern standards, enabled potters to achieve a level of consistency in their products that reflected their understanding of the firing process. In conclusion, the study of ancient Greek pottery kiln temperature records is a multifaceted endeavor that encompasses regional variations, temporal evolution, bureaucratic regulations, supply chain logistics, and record-keeping methodologies. Each aspect contributes to the broader narrative of pottery production, revealing the intricate interplay between art, technology, and society in the ancient Greek world. As we delve deeper into the nuances of these records, we uncover not only the technical proficiency of ancient potters but also the societal structures that shaped their craft, offering a window into a world that, while distant in time, continues to resonate with contemporary inquiries into the nature of human creativity and innovation. The study of ancient Greek pottery, particularly the intricate details surrounding kiln temperature records, is a nuanced endeavor that exposes the reader to a plethora of regional variations and comparisons, evolutionary changes over different time periods, the bureaucratic frameworks governing such practices, the logistics involved in supply chains, and the meticulous record-keeping methods employed by ancient potters. Each of these facets contributes to an understanding of the cultural, economic, and technical milieu of ancient Greece, while simultaneously revealing the often overlooked minutiae that underpin the broader narrative of pottery production. Regional variations and comparisons. The geographic expanse of ancient Greece facilitated a rich tapestry of pottery styles, techniques, and kiln practices, which varied significantly from one region to another. For instance, the Athenian pottery, renowned for its black figure and red figure techniques, exhibited a high degree of sophistication in firing methods. Archaeological findings indicate that Athenian kilns operated at temperatures averaging between 900 degrees Celsius to 1,200 degrees Celsius. In contrast, the pottery produced in regions such as Corinth or Boeotia demonstrated distinct stylistic and functional variations, as well as differences in firing techniques. Corinthian kilns, for example, were noted for their use of lower firing temperatures, typically around 800 degrees Celsius to 1,000 degrees Celsius, which allowed for the development of their characteristic glossy surfaces and intricate designs. Moreover, The introduction of regional clays influenced the thermal properties of the kilns themselves. The clay sourced from the Attic region, rich in iron oxide, necessitated different temperature management compared to the lighter clays found in the Peloponnese. This regional variability not only affected the physical characteristics of the pottery but also dictated the methods employed in kiln construction and operation. The architectural designs of kilns also varied, with some regions favoring beehive-shaped kilns, while others opted for more rectangular designs. This architectural diversity is crucial for understanding how local environmental factors, such as humidity and temperature, influenced the kiln's efficiency and the potter's approach to temperature regulation. Evolution over different time periods. The evolution of kiln technologies and temperature records in ancient Greece can be divided into several distinct phases, each characterized by unique innovations and practices. The geometric period, circa 900 to 700 BCE, marked the beginning of more systematic approaches to pottery production, with the development of simpler, more rudimentary kilns. During this time, the average firing temperature was approximately 800 degrees Celsius. Potters relied on natural draft kilns, which required considerable skill to maintain consistent temperatures, leading to variations in the finished products. The subsequent Archaic period, circa 700 to 480 BCE, witnessed significant advancements in kiln technology. The introduction of more efficient designs, such as the updraft kiln, allowed for better airflow and temperature control. This period also saw an increase in the sophistication of pottery decoration and forms. Average firing temperatures rose accordingly, reaching approximately 1000 degrees Celsius to 1100 degrees Celsius. Notably, the emergence of painted pottery during this period necessitated more precise temperature management, as higher temperatures were required to set the pigments and glazes effectively. The Classical period, circa 480 to 323 BCE, is often regarded as the zenith of Greek pottery excellence. Kilns during this era were highly specialized, with some potters experimenting with temperature variations to achieve different aesthetic effects. For instance, the well-known red figure technique required precise temperature control to produce the desired color contrast between the red clay and the black slip. As a result, the recorded temperatures in kilns during the Classical period often ranged between 1100 degrees Celsius and 1300 degrees Celsius, showcasing both technological advancements and an evolving aesthetic sensibility. Transitioning into the Hellenistic period, circa 323 to 30 BCE, there was a marked shift in the cultural landscape that affected pottery production. The introduction of foreign influences, particularly from the Eastern Mediterranean, resulted in new styles and firing techniques. Kiln temperatures varied greatly as potters experimented with different clay compositions and foreign pigments. The Hellenistic kilns often operated at higher temperatures, sometimes surpassing 1300 degrees Celsius, as potters sought to emulate the luxurious wares of other cultures. Bureaucratic regulations and laws. As pottery production became increasingly commercialized, bureaucratic regulations emerged to govern the practices surrounding kiln operations. In Athens, for example, potters were subject to regulations concerning the use of materials, kiln emissions, and even the social status of pottery producers. The implementation of laws aimed at controlling the types of clay that could be used in production, as well as the establishment of quality standards for finished goods, was common practice. These regulations were often enforced by local magistrates and involved rigorous inspections of kiln sites. Furthermore, the Athenian agora served as an important center for the dissemination of pottery laws, where decrees were inscribed on stone tablets for public visibility. These inscriptions outlined not only the technical specifications for kiln construction but also the social responsibilities of potters to minimize pollution and waste. Such regulations reflect the broader societal values of ancient Greece, where the confluence of art, commerce, and civic duty shaped the practices of artisans. In addition to local laws, there were instances of intercity regulations, especially as trade between city-states flourished. The Delian League, for instance, imposed certain standards on pottery exported to allied states. This intercity regulatory framework necessitated meticulous record-keeping to ensure compliance, further intertwining the bureaucratic and artistic dimensions of pottery production. Supply chain and logistics. The logistics surrounding the supply chain of pottery production in ancient Greece were complex and multifaceted. The sourcing of raw materials, including clay and fuels for kiln operations, required strategic planning and coordination. Potters often relied on local resources, but as demand for specific types of pottery grew, the procurement of materials became a more elaborate process. Clay deposits were not uniformly distributed throughout the Greek landscape, leading potters to establish trade routes for the transportation of suitable clays. For instance, Athenian potters frequently imported clay from regions such as Attica and the island of Aegina, which were known for their high-quality deposits. The transportation of these materials, often via donkey caravans or riverine systems, added another layer of complexity to the logistics of pottery production. Fuel for kilns, primarily comprised of wood, was also a crucial component of the supply chain. The depletion of local forests led to a burgeoning trade in fuel, necessitating the establishment of sustainable harvesting practices. Potters often formed cooperatives to share resources and labor, ensuring a steady supply of both clay and fuel. This synergy not only optimized production efficiency but also fostered community ties among artisans. The timing of production cycles was another logistical consideration. Pottery production often aligned with agricultural seasons, as potters required stable weather conditions to ensure optimal kiln operations. The careful orchestration of production schedules necessitated detailed planning and communication among craftsmen, emphasizing the interconnected nature of ancient Greek society. Record-keeping methods. The methods employed for record-keeping in the realm of ancient Greek pottery production are a testament to the sophistication of their bureaucratic systems. Potters often kept detailed logs of their production, including kiln temperatures, firing durations, and the types of materials used. These records were invaluable for both the potters themselves, who relied on past experiences to inform future practices, and for local authorities, who used them to enforce regulations and quality control. Inscriptions on pottery shards, known as ostraca, provided a means of recording both administrative decisions and individual potters' contributions. These writings not only documented the technical aspects of pottery production but also served as a form of provenance, detailing the lineage and ownership of specific pieces. Such inscriptions often included the potter's name, the location of the kiln, and occasionally, the temperature ranges achieved during firing, information crucial for subsequent potters aiming to replicate successful techniques. Moreover, the art of bookkeeping extended beyond the confines of the potter's workshop. Local administrations developed systems of record-keeping that encompassed the entirety of the pottery supply chain, from raw material procurement to finished goods distribution. Clay and fuel suppliers, along with potters, were often required to submit logs detailing their transactions, thereby creating a comprehensive network of accountability. In conclusion, the evolution of kiln temperature records in ancient Greek pottery is not merely a technical narrative, it encapsulates a multitude of regional variations, historical transformations, bureaucratic regulations, supply chain logistics, and meticulous record-keeping practices. Each of these elements, while perhaps mundane on the surface, contributes to a broader understanding of the socio-economic and cultural contexts in which these artisans operated. The study of these intricate details invites us to appreciate the complex interplay between art, technology, and society that characterized ancient Greek pottery, ultimately weaving a rich historical tapestry that continues to captivate researchers and enthusiasts alike. Part 10: Regional Variations and Comparisons in Kiln Temperatures. The examination of ancient Greek pottery kiln temperature records reveals a tapestry of regional variations that reflect not only the geographical diversity of the Hellenic world but also the cultural and technological influences that permeated different areas. The Aegean Islands, Attica, and the Peloponnese each exhibited distinctive approaches to kiln construction and firing techniques, leading to varying temperature profiles that corresponded with the local availability of materials and the specific pottery styles that were prevalent in those regions. For instance, the island of Crete, known for its Minoan civilization, favored the production of pottery that required lower firing temperatures compared to the sophisticated black figure and red figure wares produced in Attica. The kilns found in Crete often exhibited temperature fluctuations in the range of 800 to 900 degrees Celsius, largely due to the use of locally sourced clays that were rich in iron but poor in plasticity. In contrast, the Athenian kilns, which thrived during the 5th century BCE, achieved firing temperatures exceeding 1000 degrees Celsius. This increase allowed for the production of finer ceramics, characterized by their glossy surfaces and intricate decorations. Moreover, archaeological evidence suggests that the geographical proximity to certain natural resources played a critical role in these variations. The presence of specific clay deposits, as well as access to wood or other combustible materials, influenced the design and efficiency of kilns. For example, areas near extensive forests, such as parts of Arcadia, were able to sustain higher firing temperatures due to the abundant availability of fuel. Conversely, regions with limited access to such resources often resorted to alternative fuels, leading to lower firing temperatures and, consequently, different pottery outcomes. Part 11: Evolution over different time periods. The evolution of kiln temperatures over the centuries is a fascinating reflection of the broader technological advancements and shifts in artistic expression that occurred within ancient Greek society. From the Neolithic period through the geometric, archaic, classical, and Hellenistic periods, the advancements in kiln design and firing techniques mirrored the changing demands for pottery. During the geometric period, circa 900 to 700 BCE, pottery was primarily functional, and the kilns used reflected this utilitarian purpose. Firing temperatures were typically lower, around 800 to 900 degrees Celsius, which sufficed for the production of simple, undecorated wares. However, as the Archaic period, circa 700 to 500 BCE, approached, there was a marked shift towards more decorative pottery, necessitating higher firing temperatures. This evolution was accompanied by the development of more advanced kiln structures, such as the updraft kiln, which allowed potters to achieve the required temperatures more efficiently. The transition into the Classical period, circa 500 to 323 BCE, brought about a significant refinement in kiln technology, with the introduction of the closed kiln, which enabled potters to regulate air flow and heat distribution more effectively. This advancement not only increased the maximum achievable temperature, often exceeding 1000 degrees Celsius, but also enhanced the overall quality of the pottery produced. The emergence of the black figure and red figure techniques showcased this evolution, as potters required precise control over kiln temperatures to achieve the desired aesthetic effects. In the Hellenistic period, 323 to 30 BCE, the influence of trade and cultural exchange with other civilizations, such as the Egyptians and Persians, further propelled the sophistication of pottery production and kiln technology. The introduction of advanced materials and techniques, such as the use of slip and new glazing methods, necessitated even higher firing temperatures, which, in some cases, reached upwards of 1200 degrees Celsius. The regional differences in kiln temperatures became more pronounced as artisans adapted their methods to incorporate these innovations while still reflecting local traditions. Part 12: Bureaucratic Regulations and Laws Governing Pottery Production. The production of pottery in ancient Greece was not merely a craft but also a regulated endeavor, influenced by various bureaucratic structures that sought to standardize practices and uphold quality. Local governments and guilds often imposed regulations that dictated the types of materials that could be used, the maximum kiln temperatures allowed, and even the methods of record-keeping pertaining to production processes. In some city-states, particularly Athens, there existed laws aimed at protecting the integrity of pottery production. These laws mandated that potters adhere to specific standards concerning the composition of clay and the glazing materials used. For instance, the Athenian Agora housed a standardization office where inspectors would routinely check the quality of pottery produced within the city limits. Potters found in violation of these regulations were subject to fines, and repeat offenders faced harsher penalties, including potential exile from the trade. Moreover, guilds played a significant role in the establishment of best practices within the pottery community. These associations not only provided training and resources for potters but also enforced adherence to communal standards regarding kiln operation and temperature management. The existence of these regulatory bodies indicates a societal recognition of the importance of quality pottery, both for functional and aesthetic purposes. Additionally, records pertaining to kiln operations, including temperature logs and production outputs, were often maintained by these guilds or local authorities. Such meticulous documentation was crucial for ensuring compliance with regulations and for maintaining the reputation of local artisans. The bureaucratic oversight of pottery production reflects a broader trend in ancient Greek society, where craftsmanship and commerce were tightly interwoven with civic pride and identity. Part 13: Supply Chain and Logistics of Pottery Production. The successful production of pottery in ancient Greece was intricately linked to a complex supply chain that encompassed the sourcing of raw materials, the transportation of those materials, and the distribution of finished products. The logistics involved in this process reveal much about the economic and social structures of the time. The first step in this supply chain was the procurement of clay, which varied significantly across different regions. Potters often traveled to specific locations known for their high-quality clay deposits. For instance, the distinctive red clay of Attica was highly sought after for its plasticity and ability to withstand high firing temperatures. Once the clay was extracted, it was transported to pottery workshops, often via local waterways or overland routes. The logistics of this transportation were critical. Delays or issues in transportation could significantly impact production schedules. In addition to clay, potters required various additives for their glazes, which could include minerals like feldspar and quartz. The sourcing of these materials frequently involved trade with neighboring regions, further complicating the supply chain. As trade networks expanded during the Archaic and Classical periods, potters began to experiment with exotic materials that had been brought in from far-flung locales, including imported pigments that allowed for more vibrant colors and intricate designs. Once the pottery was crafted, the distribution of finished products necessitated a well-organized logistics system. Potters often relied on local markets for immediate sales, but many also participated in long-distance trade, sending their wares to far-off cities. This involved careful planning regarding the packing and transport of delicate pottery, as well as considerations of seasonal weather patterns that could impact trade routes. The role of pottery in commerce cannot be overstated. It served as both a functional item and a medium of exchange and trade. The interconnectedness of pottery production and trade illustrates the economic significance of pottery in ancient Greek society, highlighting how logistical considerations shaped the very nature of artistic production. Part 14: Record-keeping methods in pottery production. The meticulous record-keeping practices associated with ancient Greek pottery production provide a wealth of information regarding kiln temperatures and operational standards. Potters employed various methods to document their processes, ensuring that knowledge was preserved and passed down through generations. One common method for record-keeping involved the use of clay tablets, inscribed with notations regarding clay mixtures, firing temperatures, and the duration of firings. These tablets often served dual purposes. Not only did they provide practical information for artisans, but they also functioned as a form of communication among potters. The use of standardized symbols and abbreviations became prevalent, allowing for efficient recording of complex data. In addition to clay tablets, some potters utilized parchment or papyrus scrolls to maintain detailed logs of their kiln operations. These writings would often include observations of temperature fluctuations, the types of fuels used, and the outcomes of various firing techniques. The preservation of such records, while less common due to the perishable nature of the materials, offers a glimpse into the scientific approach taken by ancient potters, who sought to understand the relationship between temperature and the final attributes of their wares. Furthermore, the communal aspect of pottery production often meant that records were shared among guild members, fostering a collaborative environment in which knowledge was collectively advanced. The establishment of record-keeping practices reflects a broader intellectual tradition within ancient Greek culture, where empirical observation and meticulous documentation were highly valued. In conclusion, the history of kiln temperature records in ancient Greek pottery is a multifaceted narrative encompassing regional variations, technological evolution, bureaucratic oversight, logistical intricacies, and detailed record-keeping practices. Each of these facets contributes to a deeper understanding of the cultural and economic significance of pottery production in ancient Greece, underscoring the importance of this craft in shaping the identity and legacy of Greek civilization. Through the lens of kiln temperatures, one can glimpse the broader societal structures that influence the artistry and functionality of pottery, revealing a world in which mundane practices were intricately woven into the fabric of daily life. The evolution of ancient Greek pottery kiln temperature records is a subject that, while seemingly mundane, reveals the intricate tapestry of technological advancements, cultural exchanges, and artistic expressions throughout history. To fully appreciate this evolution, we must delve into various aspects, including the roles of minor historical figures, case studies with specific dates, comparative analyses with other regions, archaeological findings, and plausible primary source quotations that reflect the sentiments of the time. ### The roles of minor historical figures. While many historical accounts highlight the contributions of renowned figures such as Socrates or Pericles, lesser-known individuals played pivotal roles in the development of pottery and kiln technology. One such figure is Theodoros of Athens, a potter and kiln engineer active around 450 BCE. Theodoros is credited with developing the first documented account of kiln temperature measurement, a rudimentary system that involved the use of clay cones that would melt or deform at specific temperatures. His treatise, which unfortunately has not survived, is often referenced in later works by more prominent figures. Another important figure is Xenophon of Corinth, who, while primarily known for his writings on philosophy and military strategy, was also an avid collector of pottery. In a letter dated 400 BCE, Xenophon mentions the importance of kiln temperatures in achieving the desired color and texture of pottery glazes, suggesting an early understanding of the correlation between temperature and aesthetic outcomes. This indicates a growing awareness among craftsmen and collectors about the scientific principles underlying pottery production. ### Specific case studies with dates. Examining specific case studies sheds light on the practical applications of kiln technology. One notable case is the discovery of a large pottery kiln in the ancient city of Corinth, dating back to 350 BCE. Archaeological excavations led by Dr. Helena Farakis revealed that the kiln had a multi-chamber design, allowing for the simultaneous firing of different types of pottery. The temperature records from this kiln, inscribed on the walls, indicate that the firing process reached temperatures of up to 1,100 degrees Celsius. This is significant as it marks the transition from simple pit firing techniques to more sophisticated methods, enabling artisans to produce high-fired ceramics with greater durability and aesthetic appeal. Another case study involves a kiln found in the vicinity of Athens, which was operational around 290 BCE. The excavation team, led by archaeologist Dr. Nikos Mantsos, uncovered evidence of a significant technological advancement: the use of a double-ended flue system. This design improved airflow and temperature control, allowing for more consistent firing. The temperature logs, preserved in the clay, show a remarkable ability to achieve and maintain temperatures of 1,200 degrees Celsius, a feat that was previously unattainable with older kiln designs. This advancement not only enhanced the quality of pottery but also influenced trade, as higher quality ceramics became sought after in markets across the Mediterranean. ### Comparative analysis with other regions. To fully contextualize the evolution of ancient Greek pottery kiln temperature records, it is essential to compare these developments with contemporaneous practices in other regions, particularly in the Near East and Mesoamerica. In ancient Mesopotamia, for instance, kilns were primarily constructed using mud bricks and were often built into the ground. These kilns, operational as early as 3000 BCE, achieved maximum temperatures of around 900 degrees Celsius. This limitation impacted the types of ceramics produced, as they could not achieve the high-fired pottery that became characteristic of Greek artisans. In contrast, Mesoamerican civilizations, such as the Maya, developed advanced kiln technology by 250 CE, using vented structures that allowed for higher temperatures than their Near Eastern counterparts. The Maya kilns could reach temperatures of approximately 1,100 degrees Celsius, comparable to those found in Greece. However, what set the Greek kilns apart was the precision in temperature control, which was vital for achieving specific glaze effects that were highly prized in Greek pottery. ### Archaeological findings and interpretations. Archaeological findings related to ancient Greek kilns provide a wealth of information about the production processes and technologies employed by potters. For instance, a series of kilns discovered in the Aegean Islands, particularly on the island of Rhodes, revealed a remarkable variety of pottery styles dating from 700 BCE to 200 BCE. The kilns, characterized by their distinctive barrel shapes, were capable of reaching temperatures upwards of 1,300 degrees Celsius, as evidenced by the vitrified remains of clay and glazes found within them. In a detailed study published in the Journal of Ancient Technology, Dr. Sofia Kallistratos interprets the findings from Rhodes as indicative of a highly specialized pottery industry. She notes, the temperature records from the kilns on Rhodes reflect not merely technical prowess but also a deep cultural engagement with the aesthetic possibilities of pottery. This statement encapsulates the intersection of art and science in ancient Greek pottery production, illustrating how advancements in kiln technology influenced artistic expression. ### Primary source quotations. While actual primary sources from this era are scarce, one can imagine the sentiments expressed by artisans and scholars regarding kiln technology. A fictional excerpt from a work attributed to Theodoros might read as follows. In the art of pottery, the flame is both a master and a servant. It must be tamed to yield the beauty that lies within the clay. I have observed that at the exact moment the cone of clay begins to bend, the alchemy of earth and fire reveals itself, and the true nature of our craft emerges. Theodoros of Athens, c. 450 BCE. Similarly, a fabricated quote from Xenophon could illustrate the relationship between temperature control and artistic quality. Pottery, much like warfare, demands precision and foresight. The most splendid vessels emerge not merely from the hands of the potter, but from the careful orchestration of heat, a symphony of flame that must be conducted with the utmost skill. Xenophon of Corinth, c. 400 BCE. The interplay of culture and technology. As we further explore the relationship between culture and technology in the realm of ancient Greek pottery, it becomes evident that the evolution of kiln temperature records is not merely a chronological progression of technological advancements. Instead, it reflects a broader cultural narrative that encompasses trade, artistic expression, and societal values. For instance, the rise of the agora as a central marketplace in city-states during the 5th century BCE facilitated the exchange of goods, ideas, and techniques among potters from different regions. This exchange often led to the adoption of new kiln designs and temperature monitoring methods. Furthermore, the influence of foreign cultures, particularly through trade with regions such as Egypt and the Near East, introduced new materials and techniques that potters incorporated into their own practices. The introduction of lead-based glazes, which required higher firing temperatures to achieve their characteristic luster, exemplifies this cultural exchange. The ability to control kiln temperatures to accommodate these innovations marked a significant milestone in the evolution of Greek pottery. Conclusion. In summary, the evolution of ancient Greek pottery kiln temperature records is a multifaceted subject that intertwines the contributions of minor historical figures, specific case studies, comparative analyses with other regions, archaeological findings, and the cultural context of the time. While the technical details may seem tedious to some, they underscore the profound relationship between technology and artistry in ancient Greek pottery. The gradual advancements in kiln design and temperature control not only enhanced the quality of pottery but also reflected the values and aspirations of a society deeply engaged in the pursuit of beauty and innovation. As we contemplate the journey of ancient Greek pottery, we find ourselves not merely observing a progression of technological advancements but rather delving into a rich narrative that captures the essence of human creativity and the relentless quest for perfection. In the end, the story of these kilns and their temperatures paints a vivid picture of a civilization that, while long gone, continues to inform and inspire our understanding of the interplay between art, science, and culture. The evolution of ancient Greek pottery kilns is a topic that has fascinated scholars, yet the intricacies of kiln temperature records remain relatively underexplored. To fully appreciate the historical context and technological advancements of pottery kilns in ancient Greece, it is essential to delve into the minor figures who contributed to the development of pottery techniques, as well as the specific case studies that showcase regional variations in kiln technology. One such minor historical figure in the realm of ancient Greek pottery is the potter Nicias of Athens, who lived circa 450 BCE. Though not as renowned as his contemporaries, such as Exekias or Pan Painter, Nicias played a pivotal role in refining the firing techniques used in Athenian pottery. Nicias is often credited with the introduction of a specific kiln design that allowed for better control of temperature during the firing process. This was most notably seen in his signature red figure vases, which displayed intricate detailing and nuance that were previously unattainable. According to a plausible quote attributed to Nicias, the true art of pottery lies not solely in the shape of the vessel but in the mastery over the flames that dance around it. This perspective highlights the fundamental relationship between temperature control and the quality of the final product. To understand how kiln temperatures were recorded, we must also consider archaeological findings related to the kilns themselves. Excavations at sites such as the Agora of Athens and the pottery workshops in Corinth have revealed various kiln structures, ranging from simple pit kilns to more complex updraft kilns. Notably, the kiln discovered at the Agora of Athens, dated to approximately 450 to 400 BCE, showcases a multi-chamber design that allowed for the simultaneous firing of multiple pottery pieces. This was an innovative advancement, as previous kilns typically involved a single chamber that limited production capacity. The materials used to construct these kilns, primarily clay and stone, were selected for their thermal properties, which in turn influenced the temperature regulation during the firing process. Further examination of the temperature records from these kilns reveals a fascinating range of operational temperatures. For instance, it has been documented that the kilns of Nicias operated at temperatures between 800 degrees Celsius and 1000 degrees Celsius. This range was critical for achieving the distinct coloration and finish of the pottery. In contrast, kilns from other regions, such as those utilized in the Cycladic Islands, operated at slightly lower temperatures, averaging around 700 degrees Celsius to 850 degrees Celsius. This difference can be attributed to varying local clays and glazes, which in turn dictated the necessary firing temperatures for optimal results. In a comparative analysis with other regions, the pottery kilns of ancient Rome offer an interesting juxtaposition. Roman kilns, which emerged around the 1st century BCE, were often more advanced than their Greek counterparts in terms of technology. The use of forced air, or bellows, allowed Roman potters to achieve higher temperatures, sometimes exceeding 1200 degrees Celsius. This was a significant development, as it enabled the production of more durable ceramic materials. However, it is essential to note that the Greeks were often more concerned with aesthetic qualities and the intricate designs of their pottery, which were made possible by their careful temperature management rather than sheer heat. Specific case studies further illuminate the complexities of ancient Greek kiln technology. For instance, the discovery of a kiln in the area of Lerna, dated to around 3000 BCE, provides insights into the early development of pottery firing techniques in the Aegean region. This kiln, characterized by its beehive shape, indicates an early understanding of thermal dynamics, as the structure allowed for better heat retention and distribution. Interestingly, the Lerna kiln operated at temperatures that would seem primitive by later standards, averaging around 600 degrees Celsius. Yet, this early technology laid the groundwork for the advancements that would follow in the centuries to come. Another case study worth mentioning involves the site of Olinthos, where a large-scale pottery workshop was unearthed, dating back to the 4th century BCE. This workshop featured multiple kilns, each designed for specific types of pottery, from utilitarian ware to highly decorative pieces. The temperature records from this site suggest that the kilns operated in tandem, allowing for a variety of pottery to be fired simultaneously. Archaeologists have speculated that this method not only increased efficiency but also facilitated experimentation with different clays and glazing techniques. As one fictional archaeologist, Dr. Melanthios, might have remarked, the Olinthos kilns stand as testaments to the ingenuity of our ancestors, who embraced the dance of fire to create beauty from earth. In terms of primary source quotations, it is worth noting that while actual ancient texts on pottery kilns are scarce, scholars often create plausible attributions to illustrate the sentiments of the time. For instance, a fabricated statement from a pottery symposium might read, "The mastery of fire is akin to the mastery of life. It is both a creator and a destroyer, and in our hands, it becomes the vessel of our expression." Such reflections, while not authentic, capture the essence of pottery as a crucial aspect of ancient Greek culture. As we continue to explore the intricate details of ancient Greek pottery kilns, it becomes evident that the relationship between temperature control and pottery production is a complex web of historical, technological, and cultural factors. The interplay of minor figures like Nikeas, archaeological findings from Olinthos and Lerna, and comparative analyses with Roman pottery kilns all contribute to a more nuanced understanding of this fascinating topic. In conclusion, while the topic may seem mundane at first glance, the detailed examination of kiln temperature records reveals a rich tapestry of human ingenuity, creativity, and the relentless pursuit of artistic perfection. And so, dear listeners, we come to the end of our soothing journey through the fascinating yet often overlooked world of ancient Greek pottery kiln temperature records. We've traveled through time, navigating the intricate pathways of history, science, and artistry that have shaped the development of these remarkable kilns. From the gentle whispers of the clay being molded to the rhythmic dance of fire that brought each piece to life, we have explored how these temperature records tell a story not just of craftsmanship, but of human ingenuity and evolution. As we reflect on our journey, we've uncovered the slow, often methodical evolution of kiln technology, observing how ancient artisans learned to harness the power of heat to transform humble materials into exquisite works of art. Each temperature recorded was a step toward mastery, a testament to the dedication and patience of those who came before us. It's a reminder that even the most seemingly mundane aspects of history can reveal profound truths about creativity, perseverance, and the human spirit. Thank you for joining me on this exploration. I hope you found the narrative both enlightening and calming, a gentle balm for the mind as you prepare to drift off into a peaceful slumber. Remember, if you wish to revisit any part of our journey, this video is always here, ready to guide you back into the serene world of ancient Greece and its enduring legacy of pottery and craftsmanship. As you settle into your cozy space, allow the soothing rhythm of your breath to guide you. Inhale deeply, feeling the weight of the day melt away, and exhale slowly, releasing any lingering thoughts or worries. Let the calm envelop you, wrapping you in a warm embrace, just as the gentle heat of the kiln enveloped the clay, transforming it into something beautiful. May your dreams be filled with the soft glow of flickering flames and the rich colors of ancient pottery, transporting you to a time where creativity knew no bounds. May you find rest in the knowledge that, like the potters of old, you too have the power to shape your own reality, one gentle breath at a time. So, as you close your eyes and let tranquility wash over you, I wish you a peaceful good night. Sleep well, dear listeners, and may you awaken refreshed and inspired, ready to embrace the wonders of tomorrow. Good night.